Hello everyone, I'm Ainson Aldrich A. Amiliar from Pamantasan, Luzon, Manila, studying or having BS Chemistry as of course a fourth year student of BS Chemistry. And today I'm going to show you how to solve for the wave function of 8J orbital. So now I'll be showing you how to solve for the wave function of 8J orbital. So generally, this is the equation for the wave function of any orbital that you want to solve, like 1s, 2s, 2p, or 3d, any orbital that you want to solve. And since for 8j, I will only be tackling m is equal to 0, and of course l is equal to 7 since it's j. Then Rn is again it's 8. So I'll be solving first the easiest one to solve, which is the t. Since t is only equal to 1 over square root of 2 pi times e raised to positive or negative I m v. In this part, we will not be we will not be having problems with m because our m is just equal to 0. So if m is equal, since our m is equal to 0, then e raised to positive negative IMO or IMV is equal to 1, since any number raised to 0 is equal to 1. So we have now t is equal to 1 over square root of 2 pi. The next thing we'll be solving is the longest one, which is the s. Since s varies depending on the value of m, and for 8j we have think we have 15 of this, including 0. So we have the equation for s, which is equal to sine raised to the absolute value of m theta, and multiplied by the summation of aj cosine j theta and j theta, from j is equal to 0 or j is equal to 1 depending on the value of l minus the absolute value of m. Since our L minus M is equal to 7 minus 0 is equal to 7, so we'll be starting from 1 up to 7, just including only the odd numbers, is 1, 3, 5, and 7. And since our M is 0, then our value of sine theta will just be 1. So any number multiplied by 1 is the same number. So we have now a1 cosine theta plus a sub 3 cosine cube theta plus a sub 5 cosine 5 theta plus a sub 7 cosine raised to 7 theta. Problem here is we have many normalization constant, but we need only one to solve. So in solving s, this equation for s, part of it will be able to solve a sub j plus 2 is equal to j plus m times j plus m plus 1 minus l times l plus 1 over j plus 2 times j plus 1 a j. And since we have a3, our j here is 1, and that's what we need, the a1. So substituting the value of j, which is 1, then m is equal to 0, multiplied by 1 plus 0 plus 1, which is j plus m plus 1, which is 2. 2 times 1 is 2, minus 7 times 7 plus 1, which is 8, which is 56, over 1 plus 2, since our j is equal to 1, which is 3, then 1 plus 1 is equal to 2. 3 times 2 is 6. So 2 minus 56 will lead us to negative 54 over, of course, the product of 2 times 3, which is 6. Negative 54 over 6 can be simplified by just simply dividing 54 to 6, which is negative, or which is 9. So we have negative 9 times a1. Now the problem is for a5, since the j for a5 is 3 and not 1. So what we will do after getting the value of a5, we will substitute the value of a3 that we got earlier, which is negative 9 times a1. So we have now 3 plus 0 times 3 plus 0 plus 1 is 4, which when multiplied to 3 is 12, minus, again, the same value, which is 56, over, since we have different j value here, we will use 3 instead of 1. So 3 plus 2 times 3 plus 1, which is the same as 5 times 4, equal to 20. So we will have 12 minus 56, which is negative 44, over 20 times the value of a3, which is negative 9 times a1. Then we will get the value of 396 over 20 times a1, multiplying both sides to both numbers to 4. Dividing both of the numbers of 4. To simplify it, we will get 99 times 99 over 55 times a1. The same thing will go to a7. So our j here is 5. So again, we do it again. 5 plus 0 times 5 plus 0 plus 1, which is 5 times 6, which is 30, minus 7 times 7 plus 1, which is 56, over 5 plus 1 times 5 plus 2, which is the same as 6 times 7, is equal to 42. And then multiply it by the value we got earlier for a5. So 30 minus 56 is negative 26 over the product of 6 times 7, which is 42, times a5. And the value we got earlier for a5 is 99 over 5 times a1. Multiplying that value to negative 26 over 42, we will get negative 2574 over 210 a1 times a1. You can just simply simplify this using a calculator that will show you the simplified fraction value for this equation. Some calculators do not have that, so I also recommend that you have a software that will show the decimal, or not the decimal value, and also the fraction value. And so for this value, simplifying it, we will get negative 429 over 35 times a1. Then substituting every value that we got, we will get, and also factoring out a1, we will get s is equal to a1 times cosine theta minus 9 cosine cube theta plus 99 over 5 cosine raised to 5 theta minus 429 over 35 cosine 7 theta. So for us to be able to get the value of a1 here, we will normalize the whole equation. How do we normalize it? So we normalize it by using this equation. 1 is equal to integral of s times s sine theta d theta, where the limit is from 0 to pi. Again, if you're going to solve this in your calculator, make sure that you set your calculator to radians, or else the calculator will see pi as 3.14 and not 180 degrees. So we substitute the value of s, and since both are s, just multiply them to get this. 1 is equal to a1 squared integral of 0, or integral of cosine theta minus 9 cosine cube theta plus 99 over 5 cosine raised to 5 theta minus 429 over 35 cosine to 7 theta squared sine theta d theta from 0 to pi. So you can just input it to your calculator or the software that I'm using is Microsoft Math, a product of Encarta. Again, it's set to it is set to regions. Of course, we're using real numbers, not complex numbers. So just input the value here. I know you're seeing cosine x cube, but actually when I input it, I input it like cosine, or open parenthesis, cosine x close parenthesis cube. So I would assume that that the software I'm using read it as it is. Also, I checked it with the Casio calculator, and I got also the same value, which is 512 over 18,975. To simplify things, I'll be using this value. But if you want to do it manually, first you have to expand the whole equation to remove the square, or the square. Then simplify it by adding same terms. So this is the expanded equation for the square, and combining same terms, like for example negative 9 cosine 4 theta, you combine it with negative 9 cosine 4 theta, you will get negative 18 cosine raised to 4 theta. So I will not be reading the whole equation, moving on. So this is now the simplified, or in other terms, this is the equation wherein same terms were joined or were combined. So you can check it by also again using a calculator. In the software using it has the expand function. So expanding it, you will get this value, and this value, which is the same value that I got here. So the next step we'll be doing is, of course, distributing the sine theta d theta to each of the values that you have expanded, and then splitting the integral sign to each of the each values that you've got. So for example, you will have integral of cosine squared theta sine theta d theta minus 18 integral of cosine 4 theta sine theta d theta, and so on with the other equations. So for even powered cosines, simply you just let a letter to represent cosine theta. So why cosine theta? Because when you get the derivative of it, you will get negative sine theta d theta, which is same thing as this one without the negative sign. So you should not forget the negative sign when you are to substitute the value that you see here with to this one, so that you get integral of negative u squared du. Okay, then this is just a simple integration. When you integrate it, you will get negative u cube over 3 plus c, of course the constant, but for this type, you just remove the c, ignore the c, then substitute the value for u, which is cosine theta, then we get negative cosine cube theta over 3. So this is the whole equation when it is integrated. Now for this equation, I'll just simply show you how you will solve for this one. It's the higher value minus the lower value. So negative cosine cube pi over 3 minus negative cosine cube 0 over 3. So since we're reading is as angles from the polar coordinate system, cosine cube pi is equal to negative 1, and cosine 0 is equal to positive 1. So we will get here 1/3, since negative cosine cube theta is negative cosine cube pi is negative 1 multiplied by negative 1, we get 1, so 1 over 3. Same thing with 0, since you subtract it by 0 and we have negative sign here, negative times negative becomes positive, so we will get 1/3 plus 1/3, or 2/3. But to simply put it, you just have to add 1 plus 1 over the same denominator. So for example, if you have negative cosine 5 theta over 5 from 0 to pi, you just get 2/5. Then multiplied by 18, you get 36 over 5. So if you do it with the other values, you will get 2 over 3 minus 36 over 5 plus 1,106 over 35 minus 26,664 over 215 plus 114,434 over 1,125 minus 169,184 over 2,275 plus 368,082 over 18,175. And by using the software I'm using to simplify the equation, I also got 512 over 18,975, which is the same value if you put it, or if you input the whole integration without simplifying anything from it. I got the same value, which is 512 over 18,375. So going back to the equation, 1 is equal to a1 squared times 512 over 18,375. Multiplying both sides, so 18,375 over 512, we will get a1 squared is equal to 18,375 over 512. Then getting the square root of both sides, since we only need a1, is equal to 35 over 16 square root of 15 over 2. In my software, it gave me an equation like 35 over 32 square root of 30, simply because in math we don't have any squared values, square of any value in the denominator. So to remove it, we multiply it by square root of the calculator multiplied by square root of 2 over square root of 2, and it got the value of 35 times square root of 30 over 32. But for the sake of simplicity of the equation, I will just use a1 is equal to 35 over 16 square root of 15 over 2. So substituting a1 from the equation, we'll get now s is equal to 35 over 16 square root of 15 over 2 cosine theta minus 9 cosine cube theta plus 99 over 5 cosine raised to 5 theta minus 429 over 35 cosine raised to 7 theta. Then lastly, we'll be solving for the r, or the value for r. R is equal to negative zr over na times r raised to l, summation of bj rj, from j is equal to 0 to the value we get from the answer when we subtract n to l and to 1. So since our n is 8, our l is 7, 8 minus 7 minus 1 is 0. So we'll be starting this only for 0. So we have now r is equal to e raised to negative zr over 8a, r raised to 7 bo. So again, just like what we did with s, we will normalize the whole equation to get the bo, or the normalization constant, to get the value for bo. To normalize the whole equation, we will use integration of r times r squared dr. Why r squared, not sine theta? Since we're dealing with the r and not the theta. And take note, our r here is equal to 0 to infinity. So Substituting the equation, we will get E raised to negative ZR over 8A R7BO times, multiplied by itself, of course, times R squared dr. Expanding or simplifying the equation, we will get BO squared integral of E raised to negative ZR over 4A. So why did it become 4A? Well, since in the rule of multiplying numbers with this same number with power, we simply add the powers of the number. So if we add negative ZR over 8A to negative ZR over 8A, we will get negative 2ZR over 8A. And so to simplify things, 2 over 8 is also equal to 1/4. So that's why we have ZR over 4A times R times 16 dr. So from this model, you will see here that to get the integral of this equation, you will get the factorial of the n, or r raised to, or whatever the value the r is raised to, over q times n plus 1. Q is, for this example, q is negative z over 4a, right, raised to n plus 1. So to solve this, we will get BO squared, B sub 0 squared multiplied by 16 factorial over Z over 4A raised to 17. Now I know 16 factorial is a really huge number, but in this case, I really want to simplify the whole equation. So I got the whole factorial of the 16, which is 20,122,789,888,000 over Z over 4A raised to 17. So multiplying both equations, since this is still equal to 1, we multiply both equations to Z over 4A raised to 17 multiplied by 1 over 20,122 billion 789,888,000, so that we will get the value for BO squared, which is this one. Then getting the square root of the whole equation, you get BO is equal to Z over 4A times 17 over 2 multiplied by 1 over 120,160 square root of 1,430. Now I will not be discussing much of the simplifying the whole equation, but if you want, you can just use the software that I'm using, or any calculator that is able to simplify the equation that I gave. So for me, when I simplified it, I got Z over A times 17 over 2 raised to 17 over 2 multiplied by 1 over 15 trillion and 54, or 15 billion and 54,469,120 multiplied by 1,000 square root of 1,430. In the calculator that I used, it got this equation, or this value, since again it multiplied the one that I got with square root of 1,430 over square root of 1,430. So substituting the value for BO that we got, we have now R is equal to E, so negative ZR over 8A multiplied by Z over A is 17 over 2 times R raised to 7 over 15,154,469,120 square root of 1,430. So lastly, the alpha and the beta are just simply the ms, or the magnetic spin of your electron. And since in any orbital you will see the half arrow signifying that the other one is positive 1/2 and the other one is negative 1/2. So the alpha is positive 1/2, the beta is negative 1/2. So the wave function is split into two to show that the electron is either facing up, which is positive 1/2, or facing down, which is negative 1/2. But it doesn't really mean it's facing down. It's only just it's the spin, how the electron is spinning. So the whole wave function for 8J with ms is equal to positive 1/2 is simply you just substitute the values that we got for R, for the S, and for the T, and then the alpha value that we got earlier, which is positive 1/2. So we get e raised to negative zr over 8a times z over a raised to 17/2 multiplied by r 7 over 15 billion 854,469,120 times square root of 1,430 multiplied by the value of s that we got earlier, which is 35/16 times square root of 15/2 cosine theta minus 9 cosine cube theta plus 99/5 cosine raised to 5 theta minus 129/35 cosine raised to 7 theta multiplied by the value of t 1 over square root of 2 pi, then the value of alpha, which is positive 1/2. The other one's just the same, but instead of multiplying by positive 1/2, we multiplied by the value of beta, which is negative 1/2. But in this equation, the only difference is the positive 1/2 and the negative 1/2. Since I only got the m, which is equal to 0. But in the other orbitals, like m is equal to positive negative 1/2. The e that we have earlier with the t, they have to actually convert the e I m phi to cosine phi minus I sine phi. But that's not a problem for me since I only have m is equal to 0. So there you have it, the value for the wave function of 8J. As you can see, we only have cosine theta as our angles. So most probably you will see this orbital in the z, or you will just see the orientation of the shape of the orbital in the z coordinate, in the coordinate system. Since z, when you convert z to the polar coordinate system, you will get r cosine theta, which is normal to any orbital that has m is equal to 0. But of course, it has the cosine theta because s only has a sphere shape even if it has m is equal to 0. So there you have it. I hope that you learn something from what I did, from what I get. I suggest that you will use a calculator to simplify everything and to take less time in solving equations like this one. So thank you for watching, and God bless everyone.